parents, in an effort to help with the test for chapter number 4, I ran through some different options of what to have you do, and it's really up to your discretion. If you feel comfortable with doing the do-out board all by yourself and choosing things, then go ahead and do it. But I kind of thought that since most of you do not have the teacher's guide and the annotated solutions do not show you answers for the test for chapter 4 because it's a performance test, I figured that I would choose a few elements for you, show you what they're supposed to look like, show you how it's supposed to be read, so that you can watch your students and have some authority on whether or not they're doing it correctly. So I wanted to empower you to be able to do this to help them through. So the very first element that we're going to do is aluminum. The atomic number of aluminum is 13. They can use the periodic table to find this and read what number it is. So then what they'll have to do is they'll have to take their own personal do-out board and they'll fill all of the circles with the appropriate number of electrons. So as you see here, I have them all filled up, and I hope you can see this. You see my little red and white dots in here? Those symbolize my electrons, just like the little orange and white dots symbolize the electrons for your kids' do-out board. So what is important is that you hear them read what it means that when they're on this board. So anybody can fill them up with circles, but they need to be able to explain what those mean. So let me read the board to you, and then you will look for the certain words that I say with your students when they do it. So as we see, aluminum has 13 electrons. 2 of them are in the first energy field in a spherical rotation. 2, 4, 6, 8 of the electrons are in the second energy field, but 6 of them are in the pear-shaped. 2 of them are in the spherical shape, and in the pear-shaped orbit, there are 2 in the X orientation, 2 in the Y orientation, and 2 in the Z orientation. There are 3 electrons in the third energy level. There are 2 in a spherical orbit, and there is only 1 in the pear-shaped orbit in the X orientation. Okay, the second element that I've chosen for the chapter 4 test is sulfur. So the atomic number of sulfur is 16, and the abbreviation is S. Again, they can use their periodic table to look at it. So with the electrons being total of 16, then you're going to have 2 electrons in the first energy level. You will have, again, 2, 4, 6, 8 electrons in the second energy level. 2 of them are spherical in orbit. 6 of them are pear-shaped in orbit. You have 2, 4, 6 electrons in the third energy level. Now this gets to be a little tricky. You have 2 electrons in the spherical orbit. You have 2 electrons in the third level pear-shaped orbit in the X orientation. You have 1 electron in the third energy level pear-shaped orbit in the Y orientation, and you have 1 electron in the third energy level pear-shaped orbit Z orientation. So that is the element sulfur. Okay, so here's the last element we're going to do for the chapter 4 performance test. This is the element selenium, and it has the atomic number of 34. So that means it has 34 electrons in its structure. You can see that we filled up the first energy level in the spherical rotation with 2 electrons. We have 2 electrons in the second energy level, spherical rotation. We have 6 electrons in the second level p orbit in the x, y, and z orientation. We have 2 electrons in the third energy level, spherical orbit. We have 6 electrons in the third energy level, p orbit, x, y, and z orientation. We have 2 electrons in the fourth energy level with the spherical orbit. And we have 2, 4, 6, 8, 10 electrons in the third energy level with the D-shaped, which is dumbbell-shaped orbit. And we have, this is tricky, we have 4 electrons in the fourth energy level pear-shaped orbit, but we have 2 in the X orientation and only 1 in the Y orientation and 1 in the Z orientation. It doesn't matter which colors they are because the colors just represent that one goes in one direction and one goes in the other direction. That's the spin quantum number. So it doesn't really matter which color these are, as long as they have 2 in the X orientation, 1 in the Y, and 1 in the Z. Because, as we talked about in class, it fills up like it's a sink, and they fill 1 piece per cup before you add the other electron in. I hope that makes sense to you. If you are questioning about the doo-wop board, you have these cards in the back of the manipulative packet. On one side it says doo-wop mania and gives you the name of the element. On the other side it shows you exactly how the doo-wop board should be filled in. If you have any questions, go back to those. We did sulfur, aluminum, and selenium as the performance test. Hopefully this helps you so that you guys can correct and feel kind of confident in what they're doing. I will be out of town, but I will be able to access my email and my texting. So go ahead and shoot me an email or a text if you have a question. So I hope you have a great day, and I'll talk to you guys later. Bye.